So before we begin the hands-on sessions, we have a short presentation on what OpenQuake is, and what are the other tools that help support the building of hazard and risk models for earthquakes that GEM has available for you to download and use. The focus of this workshop will be the OpenQuake engine, but through this presentation, I also wanted to let you know that there are other tools that are more useful for the stage where you're developing your own earthquake hazard risk models. So OpenQuake engine is the software that you will use to run your seismic hazard risk calculations once you have built your exposure, vulnerability, and seismic hazard models. So this is just a short introduction to OpenQuake, and then after the lunch break, we'll dive into more of the details about the software itself and how we use it for different kinds of calculations. I think you saw a version of this slide before in the presentation by Catalina. So we have, in terms of the software and modeling tools, the core software is the OpenQuake engine, which is what you would use to run earthquake hazard and risk calculations. As I said, we have several supporting tools for building your models. And then we also have the OpenQuake platform, where you can find collections of national hazard models, exposure models, regional hazard models for the ones that I was mentioning before, with the European harmonization of the seismic hazard across Europe. All of those projects you can find on the OpenQuake platform. So the OpenQuake platform is an online venue. It's a website where you can create an account very quickly, and then you can see what's already available, what kind of documentation is there, the metadata of all of these models and tools. So the OpenQuake platform is an online venue, and then the engine and tools are softwares that you can download on your laptop. So now coming to the OpenQuake engine and the modeling tools. So the engine forms the core of the calculation software, but then there are several supporting software. So all of them are Python-based libraries. So for hazard modeling, you have the OpenQuake catalog toolkit. So this is something that you can use for working with earthquake catalog. So declustering analysis, cleaning up your catalog, and you have the earthquake source toolkit, which is now being built into the OpenQuake engine. So this is for building source geometries, assigning good relationships to your sources, and building out your source models that Michael was talking about earlier in the morning. Then there's a toolkit for working with ground motion records. So this is something that you could use for building out your own GMPs, fitting functions, or looking through existing functions and seeing which GMPs that are already built into OpenQuake would be suitable for your tectonic regions. On the risk side, we have the OpenQuake Risk Modelers Toolkit, which is, again, a Python-based library for simulating numerical models of buildings and deriving fragility and vulnerability functions for different kinds of structures. So this is something that you could use for deriving fragility of vulnerability functions for structures that you might find in your area of interest. So Mario mentioned that NRCan has been working recently with UBC, a group of structural engineers at UBC. They started using the Risk Modelers Toolkit to derive seismic fragility and vulnerability functions for the building types that Mario was mentioning that you can see that are specific to Vancouver and areas surrounding. Then OpenQuake engine will be the focus of this presentation. And then we have other supporting services, which are cloud-based experimental services for going through the results of your hazard and risk analysis and interrogating or looking through the results in an interactive way. And we have plugins for GIS software, a plugin for QGIS that we will also demonstrate in the hands-on session today. So that's an overview slide of all of the tools that we can find on the GitHub page for GEM. So these are some of the tools that we'll be using in the workshop today and tomorrow. The OpenQuake engine itself is primarily a software for the calculation of earthquake hazard and physical risk. We mentioned physical risk because we also have at GEM a small team working on social vulnerability and socioeconomic risk, and how earthquake hazard and risk get translated into societal impacts. But OpenQuake is currently software for the calculation of earthquake hazard and physical risk. It's a Python-based software. 95% of the code base is in Python. All of the development happens in public. So if you go to the OpenQuake landing page, on the website for the workshop, you have a set of links. You can see the GitHub page for OpenQuake. And if you go to that page, you'll see the changes that are happening to the OpenQuake code base in the last couple of hours even. So it's also a place where if you have feature requests, or if you're finding some bugs or other issues, you can open up say issues or tickets. And if you are interested, you can also contribute your code into the OpenQuake engine. There's a very collaborative approach where you can submit your code into the OpenQuake code base, and several people have done this already. Even KNR can. There have been many contributions coming from outside of GEM. This is the landing page for the OpenQuake engine. It's a source code repository. So you can clone this repository onto your own laptop if you're interested in participating in the development of OpenQuake engine, or modifying the source code to suit your own purposes, which may not be something that is available out of the box in OpenQuake. And if you're interested in developing some specific applications on top of OpenQuake, you can do that through downloading the source code and working with your own copy of OpenQuake. It has an open license, so you're free to use OpenQuake for any non-commercial purposes. The development of any new code or changes in the code are overseen by a very rigorous testing mechanism. So we have, let's say, anytime new changes are pushed into the OpenQuake code base, a set of quality assurance tests and unit tests are run automatically. They're triggered automatically, and then if any of these tests fail, the new changes cannot be merged into let's say, the master version of the OpenQuake engine. So only when all of these tests pass, new changes can be merged into the OpenQuake engine code base. So it's run through what is called a continuous integration system. This is a method of working with testing and quality assurance. So there are two kinds of tests that happen with the OpenQuake engine. The first kinds of tests are called unit tests, which are testing functional working of the different modules of the OpenQuake engine. So these are not necessarily testing for numerical accuracy, but just checking if all of the functional modules are working as they should be. And then we have more scientific testing, which is checking if the hazard and risk calculations are producing results that you should expect it to produce. So these would include the tests such as the peer set of tests for the hazard calculators, and we have similar tests for the risk calculators as well. We also, from time to time, engage in comparisons against other software that are available for hazard analysis. So far, we've not really come across any other similarly open software for risk analysis. So that comparison has not yet been done. We've done a lot of comparison of the hazard components of the OpenQuake engine with other software. And some of these publications are also available in scientific journals. So it's open and transparent. It's based on Python. We have a lot of testing on the OpenQuake engine. It's also very modular. So if you're not interested in using the entire OpenQuake engine software, you can use specific modules that may be of interest to you. So if you're only interested in GMPs, you can work with the hazard library of OpenQuake. If you're only interested in bringing in your own ground motion fields or shake maps and then starting from there and computing risk, you can do that. So you can use pieces of the OpenQuake software that are useful for you. OpenQuake has been quite widely adopted in the last 3 or 4 years across different countries. Since last year, the USGS has shifted to using the OpenQuake hazard library for their online shake map service. So to produce the ground shaking maps given rupture parameters and ground motion records. It's available on several operating systems. I mean, it would be difficult to find an operating system on which now you cannot run OpenQuake on. So there's installers for Linux, Mac, Windows. You can also install it on a cloud platform. So you can run OpenQuake on Amazon's AWS service or similar on Google Cloud Computing engines. Or if you have your own server with a multi-node, you can install OpenQuake with the multi-node support to run large-scale hazard analysis or risk analysis. We try a lot to keep the documentation in pace with the developments of the OpenQuake engine. So we have a user manual for OpenQuake 3.7. If you look through the datasets that you downloaded, one of the folders has the manuals for the current version of OpenQuake. And also we have some supporting documentation for the underlying risk science and the underlying hazard science that are also available on the GEM website. So what are the main computing capabilities of the OpenQuake engine? What kinds of hazard and risk calculations can you do with the OpenQuake engine? For the seismic hazard, say the 3 main types of calculations that you can run would be scenario hazard analysis. So this would be given an earthquake rupture, producing maps of ground shaking intensity. Then the second type of calculation that you can do is what we call a classical probabilistic seismic hazard analysis. So this is going back to the original publication by Alan Cornell in the 1960s, which goes through seismic hazard computation at a single site or a group of sites through a numerical integration approach. So combining the contribution from all of the sources surrounding this region of interest that might be contributing to the seismic hazard at those locations. So you calculate the seismic hazard contributions from all of these and sum them up to get your probabilistic seismic hazard at those sites. And then the third type of calculation that you can do is an event-based probabilistic seismic hazard analysis. So if given your seismic hazard model, you can simulate a catalog of earthquake events spanning a time period of maybe 10,000 years or 100,000 years. So this is now you're doing a Monte Carlo type of analysis. And so for each of these earthquake events that are simulated in your earthquake catalog, you can compute ground shaking maps and then come up with statistical ways to estimate your seismic hazard curves or seismic hazard maps or the uniform hazard spectra. So we'll talk a bit more about this in tomorrow's session on the probabilistic hazard and risk analysis. So scenario hazard analysis is something that we'll do in the session after lunch today. So this is given a specific earthquake rupture with a given magnitude, a given rupture geometry, given location of the hypocenter. What could be the ground shaking intensity that you could expect in the region surrounding the earthquake? So this is scenario hazard analysis. The probabilistic seismic hazard analysis would link very much closely with what Michael talked about earlier this morning. So so OpenQuake is being used for these large regional level hazard analysis. So here I'm showing you the hazard map produced for Europe as part of this hazard harmonization project that concluded a couple of years ago. And this is an example of a stochastic event set produced for central Italy, obtained again using the same hazard model covering all of Europe in 2013. I think you saw a version of this slide also in the presentation by Catalina. Again, where the places that OpenQuake is already being used. Share is the project on harmonization of seismic hazard in Europe. Sarah is a continuation of that project. This is a group of close to 24 European countries working on estimating seismic risk across all of Europe. Then there were similar projects in the Middle East, Central Asia, then Central America and the Caribbean, South America, and Sub-Saharan Africa. And now we've just begun a similar project in Southeast Asia with the 10 ASEAN countries. Several countries have officially adopted OpenQuake or are in part of the transition to OpenQuake, using OpenQuake for estimating the national hazard maps, and in some cases also moving forward into risk maps, Canada being one of the examples. As I mentioned before, the USGS has shifted to using the OpenQuake libraries for their shake map system. And components of the OpenQuake engine library have also been used in several local and national projects. For example, Portugal has started using OpenQuake for developing near real-time ground shaking assessment for earthquakes in Portugal. OpenQuake has been used in a couple of SHAC level 3 PSHA analysis for nuclear sites, one in Europe and one in South Africa. So this is projects that have already been finished. Then recently we've been seeing OpenQuake also being used for induced seismicity projects in both in Europe and South America. So these are just examples of where OpenQuake is already being used in the recent past. On the risk side, again, the capabilities are similar to what I showed on the hazard. So each of the hazard calculators can be linked to exposure and fragility and vulnerability models to go forward into damage and loss analysis. So the scenario hazard calculators could be linked with fragility and exposure models to be able to run scenario damage and loss analysis. And then similarly with the probabilistic calculators, you can do probabilistic damage and loss calculations. So beyond the basics, you can also go deeper and look into the sensitivity analysis, look into uncertainty propagation, all the way from your source models to your risk estimates, and understand how the uncertainty gets propagated through all the various stages of your risk modeling, and see what are the effects of including or neglecting different kinds of uncertainty in your models on your final risk estimates, and what kind of confidence intervals you can have on your final risk estimates. Recently, we've also been using OpenQuake. We've been seeing uses of OpenQuake in assessment of losses and repair time estimates and possible disruption of lifelines. This is a study that we did in Portugal. We're beginning a similar study in Canada as well for transportation systems and lifelines. So far, our work has been mostly focused on building damage and losses, but now we're slowly moving forward into other areas of infrastructure. So we saw the stochastic event-based hazard calculator. You can use that calculator to move forward into probabilistic damage and loss estimates for different scales. So this could be at the city level for an individual building, or you can go all the way to national level loss analysis, or even regional or global level risk analysis using OpenQuake. So we're showing examples of these projects that we did in India. These are all multi-year efforts involving several collaborators in the regions. So OpenQuake can also handle the most complex hazard models that you can find. So for example, the 2014 rupture forecast for California included 1,440 source model branches. And then for the 5 ground motion prediction equations, we have close to 7,200 branches on the logic tree. And OpenQuake, we designed a specific calculator just for California to be able to handle this amount of information in the hazard models. So we were able to compute the hazard and the risk for all of those branches in the logic tree within a matter of few hours. So OpenQuake has the capability to handle very complex hazard and risk models. And just wanted to show you some of the examples of regional projects. So these are beyond the national level. So these are collaborations between neighboring countries to work together to understand what kinds of information you have available in other places that could be used for your own hazard models, like Michael was mentioning before. Since you may not find long earthquake catalogs in central and eastern Canada, you would like to look at areas around the world that behave in a similar tectonic manner and be able to derive some knowledge or information from other areas that you can bring into your own models. So these are examples of efforts that we've been involved in South America. So this was a collaboration between 7 of the Andean countries who pooled into their expertise on hazard and risk modeling and came up with a regional level seismic hazard and risk model. These are some of the results. So we came up with a fault database for all of the continent, and then we went all the way through seismic hazard and loss computation. So this was also a 4-year effort involving several collaborators from the 7 countries. So these would be collaborators from the government, from the private sector, and from the academic institutions working in those areas. Once we build these models that cover countries or regions, a key aspect of the work going forward is calibrating those models. So this is something that we've been doing more in the last year. Looking at the estimates produced by your probabilistic models, looking at the estimates produced by your different scenarios, comparing these with historic events that have occurred in the last couple of decades, and running different kinds of checks to see if the results produced by these models make sense. So these are again examples of validation and calibration of our fragility models in this case, looking at different building classes, building structural types, and then across countries comparing annual collapse probabilities, annual loss ratios, things like this. This is the results for the average annual losses across the entire continent of South America. For a few earthquakes, since we have now databases of the exposure at pretty detailed level for most countries around the world, we're able to run near real-time estimates of damage and losses for earthquakes that happen. And so we usually don't do this as a matter of practice at GEM. Only if we receive requests from the countries affected by these earthquakes, we do run these simulations and provide back our estimates of where the damage is likely to be high or what kind of losses you might expect to see. So this is something similar to the USGS pager service, but informed by our exposure models for those countries and our fragility and vulnerability models for those countries. We're also we signed an agreement with the USGS where in the upcoming near future, the USGS will be using GEMS models and OpenQuake to estimate damage and losses for events that happen near real time, and then calibrate these models with the pager system. And then the eventual goal is to have both estimates available through the USGS pager service. Very quick estimates based on the pager methodology, and then maybe within a few hours or within a couple of days, estimates also from the GEM models and OpenQuake. So for the earthquake that happened in Ecuador, as soon as the shake map was available, OpenQuake has a capability to connect with the USGS shake map service, download the shake map for different events, and connect that with your exposure and fragility models to estimate damage and losses for that event. So these are estimates and maps that we were able to compute for this event that we sent back to the government of Ecuador after this event. This is something that we will talk a bit more about in the session after lunch on scenarios. So as part of this global modeling effort, we discovered that many countries do not have sufficient coverage for seismic fragility or vulnerability functions for the predominant building types in those countries. So in the last couple of years, we've developed a basic set of fragility functions and vulnerability functions that can be used for your analysis. If you do not have your own local fragility or vulnerability functions that you can use for your models. So we had a similar set of functions for Ecuador, which we used for producing the damage and loss estimates. What are the upcoming areas of research or work or future development for OpenQuake and extension of OpenQuake? We were part of a World Bank Challenge Fund with a consortium of different organizations to try and develop a data scheme and data sets for generating a multi-hazard database, because we already have an exposure database for earthquakes covering the entire planet. The idea was to develop similar data sets and methodologies to be able to use what is already available for earthquakes to see if that can be used for other hazards as well. Development of an open repository to store exposure data for countries around the world. And similar work to develop a building taxonomy that can cover different kinds of perils. We have a GEM taxonomy that works very, very well for earthquakes, but now the idea is to extend that to other perils. So just to conclude the presentation on the introduction to OpenQuake. So OpenQuake is an open source software for earthquake hazard and risk assessment. The development happens in public through a continuous development environment. It has a series of unit tests and quality assurance tests before any new changes are merged into the OpenQuake code base. And we provide support for the OpenQuake software tools, and there's documentation for all of these softwares available on GEM website. There's easy installation methods for Windows, Linux, and Mac. It also runs on cluster installation, so it offers parallel computing for large-scale hazard and risk calculations. One of the key aspects of OpenQuake is the capability to compute hazard and risk simultaneously. So if you have an earthquake hazard model, it's very easy to connect that with exposure and vulnerability to compute risk. Then there's a lot of flexibility on how you define your exposure model. There's no you do not have very strict requirements about what information you put into your exposure, similar for the facility. And there's a lot of flexibility in the calculation parameters. So it's not boxed into using any set of default values. It offers you a lot of leeway in building very complex hazard models. And that was what I wanted to share in this part of the talk. And then once we come back, we'll move more into hands-on working with OpenQuake. More questions?